Hello, Terry here, Hot Wrench Fabrication. Coming to you from the Hot Wrench Fabrication shop for another little video. Got my little drift car back in here. It's a customer of mine. The little drift car is not doing drift car things. Came in on a hook, crank no start, and it was actually pretty easy to diagnose. She thought it was a fuel pump problem, which there is a fuel pump problem, but turned out that the connector in the ECM wasn't plugged in all the way and it kind of worked its way loose. So plugged that in, got it started right up, but I need to address something back here that's not good. It is not a proper installation of said wiring. So got this badass dual fuel pump system made by Radium Auto. It's got two fuel pumps in there, and I have it wired up going to two relays, which is good. And over here we have two fuses, which is also good. There is a circuit protector over here, and it's wired on the correct side, so we got two wires going in there. Those two wires feed my relays, and then my relays feed the fuel pump. All that is good, except wiring is entirely too small. So she blew a fuse at the track last time she was out. It had, I think, a 20 amp fuse in there, so they put a 30 amp fuse in it, which is fine if you have the wire to support that. So the problem is this pump recommendation is 20 amps. 20 amps requires a lot bigger wire than what we have on here. This wire is pretty small. It looks like it's 14 or 16 gauge. No, that's not nearly big enough. So 30 amps is, I believe, 10 gauge. 20 amps is 12 gauge. So 12 gauge wire is quite a bit bigger. I have some over here. So this is 12 gauge wire. And this is the size of the wire required for 20 amps. So you can see the difference in size. Yes, size does matter in this case. So the problem is when you run too small of wire, then the voltage or the amperage requires, you're going to start developing some heat. Hang it. Hold, please. Okay. So while I was trying to get these unplugged, the wires actually just popped out. And you can see that wire. She's all crispy and melted. And the other wire is also crispy and melted. That's no bueno. So they had a bad connection, and you could see right there that it was starting to melt the connector too. So the reason for that is just more amperage than the wire can handle, and the extra amperage is heating the wire up and it's melting the connections. So that's bad, obviously. I mean, she could have ran this thing too lean and burnt the motor up. So all this wiring needs to be redone. And I mean, they did a, pretty decent job. They got some sheathing on there. I would have put some heat shrink on here and made it a little bit nicer. But we're gonna upgrade those relays to this guy right here. And you can see that whoa, man down. You can see that the wires are huge, quite a bit bigger. So if you don't know how a relay works, it's got a little chart on there. Basically, it's a small switch controlling a big switch. That's the easiest way to describe it. So we have 4 basic wires on here. There's actually 5, but the middle one we usually don't use. So the black wire and the white wire, that controls the coil. So there's a little coil on here, It's an electromagnet. And when you energize that, it pulls contacts over, which connects my red one and my blue one. So you can see how big the red one is. It says right on there that this is a 12 gauge wire. So this is a 30 amp relay, 12 gauge wire, hooked to a 12 gauge wire, and that's what's going to run these pumps. So I'm going to wire these in there. So basically I'm going to need some power. So instead of running the power from all the way over there with two separate wires, I'm going to put this little fuse box in here. Kind of nice. I'm going to run one big cable from my power source over there. The one big cable goes onto this end right here, and it actually powers up this whole entire thing. This is overkill, but it's just something that I had laying around. I can get several different circuits on here. Once again, you have to be careful. If I run a lot of big amperage circuits, I have to make sure that the wire going in here can handle all that. If I only have like a 10 gauge wire going in here, I can't handle 12 30 amp circuits. The whole thing's going to melt down. What I like about this style is it also has a ground. Right now the ground is sitting on here, which is not great, especially if they didn't grind some of that paint off before they put that screw in there. We have a ground right there, so we need to utilize that. So I'm going to run another wire over to this ground, and then there's 3 wires right here that I can hook into that and make it nice. So the problem with running this is if you have a little bit of high resistance, then that affects the whole circuit. So the way a 12 volt circuit works is you have basically Ohm's law, which is 1 amp goes through 1 ohm of resistance for 1 volt. So the way the circuit works is the total consumption of voltage through the system has to equal source voltage. So source voltage is obviously 12 volts, right? So if I have 12 volts running through this wire all the way through here, goes into my relay, comes out, goes into my pump, and then goes into a ground. The total voltage consumed from here to here has to equal source voltage. Well, if I have a little bit of high resistance on this ground, because it's not making a good ground, that's going to actually consume some of the voltage. If I have a wire that's too long and not big enough, that's going to consume some of the voltage. So if this consumes 1 volt, and this connector over here consumes 1 volt, well, now I have 10 volts to run my pump. Now, it's a bit of exaggeration, but that's basically how it works. So it's really important to have all this stuff matched up to where it's supposed to be. You know, they had a 20 amp fuse in there, they put a 30 amp in there and got it to go, but now we're melting relays and stuff because the volt or the size of the wire wasn't big enough for the amount of amperage that was going through there. So we're going to fix that. We're going to make it nice, and I'll kind of show you how I do some of my wiring. I like to put heat shrink on everything and make it look nice. So we'll get all this stuff cleaned up, and we'll take you along for the ride. All right, let's use Ohm's law to kind of figure this stuff out. So Ohm's law is volts over amps times resistance. So if you have any 2 figures, you can always figure out the other one. So volts, obviously on a car, it's going to be 12 volts. And then when I looked up that fuel pump, the manufacturer recommended 20 amps. Right? So if we take 12 volts, divide that by 20 amps, we get 0.6 ohms. So we can't have any more than 0.6 ohms of resistance going through that system. So if we have a little bit of high resistance because our wires are too small, or you have a bad connection, or you have a bad connection on your ground, let's say our resistance goes up, so we have 20 amps times 0.8 ohms. So now all of a sudden we need 16 volts to make that same circuit work. Well, we're not going to get 16 volts out of a 12 volt system. So now we're trying to get an amperage going through an improper circuit, and that's when we start getting heat and when we start melting things down. So just 0.2 ohms of resistance difference makes 4 volts difference on the circuit. So resistance is huge on a system when you're designing it, and high resistance is caused by improper conductor size, improper connections, all that kind of stuff. So hopefully I didn't make that too confusing. Got the old wiring stripped out. That was pretty easy. And now I'm working on the new stuff. There's the old stuff down there. So first thing I always do is mount my components. So put that in there, put the relays back basically where they were, because that was a pretty good spot for them. And now, so this is the old relay. Kind of a weird looking deals, really small pins in there. The new ones are big flat blade, kind of like what I'm used to. So that goes obviously hand in hand with the bigger wires. So these guys were, where are we at here? Well, hold on. What do I do with the, oh, here we go. Here we go. So this was the old ones. You could see that bubble right there. That's where it was melting. That terminal right there was getting super hot and melting through. Same thing on this one. No bueno. So both of those were melting. So we're going to fix that. So I had some cable laying around. This is a little too big for the power side, but it'll work. And then this is my ground. So better to go a little bit overkill than underkill. So all I have to do now is just put the power back over there where it was. I'll put my ground on the battery, and then I'll run those two all the way around to power and ground, and then run my wires to the relays. So piece of cake. So I got power and ground hooked up. Power under yonder, ground right there. And that nut runs along this nice little braided line over here. So I got power here, and that's going to power up this whole entire thing, and then ground over here. That grounds all this. So now I'm going to hook up these two relays. So like I said before, we got low amps or low power going into high power. So basically the way the relay works is you have power and ground on 85 and 86. So that's these two vertical ones here. And usually it doesn't really matter which way you hook up power and ground. It could be ground activated or it could be power activated. Depends on how the computer works. This particular one is computer works off of power. So you can see how small these wires are. So the computer sends out a power signal to the relay, which is the white wire, and the black wire is going to be grounded. That's going to go over here. And then once that grounds, the contacts inside here will connect 30 and 87. That's going to be the blue and the red. So the red or blue, it doesn't really matter. I'll probably put the blue on here for power, and then I'll run my red over here to 12 volts. And then I could run a ground wire from here to here, here to here for both of those pumps. And that'll be it. Piece of cake. So the reason why we can get by with such small wires on this is because the coil side of the relay only takes about 0.7 milliamps to make the contact. The contact side of the relay is where you get your 30 amps from, and that's the one that has to have the bigger wires. So we will get this all wired up. All right, so first thing I'm going to do is hook up the ground to this relay, because that will be a piece of cake. What I'm going to do is just take a little chunk of that off there. Put the little terminal on here. So a little bit of controversy or debate, I guess, between soldering and crimping. Most people like to solder these ends on, and some people just like to crimp them. Well, if you look at the factory, like Chevrolet, all of their terminals are actually crimped on. And the problem with soldering is it makes it brittle. There we go. So it makes it brittle right here at the connector. When you get the solder on there, it makes the wire itself hard. And with vibration and stuff, with this rocking back and forth, you can actually break the connection right there. So that's why I like to just crimp them. If you get a good crimp on there, it's smashed all the way around. Put some heat shrink on there. That keeps it sealed up and it's not going anywhere. Sometimes you can't get the heat shrink over the end of your connector, so make sure that you are working with the right size. Little torchy torch. Alright, so I like to use the Harbor Freight marine style heat shrink. You can get these little containers for I think like $5.99. But the marine grade has like wax in there, so when you heat it up, it seals the whole entire circuit, which obviously keeps the moisture out of it. So that's nice. Alright, so we're going to actually switch this wire. So this, like I said, this actual unit right here, this fuse box is completely overkill. It's got way more spots and terminals in there than I need, but it'll be good for future expansion if we need to do that. And put that in there. And these screws are so small. There we go. Okay, and then obviously that would go in right there, and that's one connection. Piece of cake. So now I think I'll go ahead and do my power since it's right there. So power to the blue right here, and then this red one will actually go to the pump, so I'll have to make a little extension on there. And then one of these yellow ones goes onto the white, and that's it. Piece of cake. So I'll show you after I'm done, because it's just rinse and repeat, but you can see it's nice how they go in there. Be right back. So in conclusion, we have finished the wiring, starting off with the positive right over yonder, and that is protected by this circuit breaker right here. And we have our negative right on the ground where it should be. And then that runs all along here, runs over here, and then I got my positive and my negative. And from there, my positive with two 30 amp fuses going into a 12 gauge wire goes into the relay, coming back out of the relay on these two red ones, and then goes into the fuel pump. And then also we got two grounds going into the ground side. Ground wires are just as big as the positive, very important. And we have room to expand. Literally like every one of these, I can hook up a circuit, and then we have a bunch more grounds to hook to. So I did put the other grounds that were already there. So when you fire up the vehicle, these two yellers down here sends a positive signal, which is actually kind of unusual. Usually grounds the relay, but this time it sends positive. So that kicks on the white one, and then the black one right here goes to the ground. So of course that kicks on those relays, and I did test it and it works. So yeah, that's your basic wiring, all nice and clean, room to expand, and then this little cover goes on here in case you drop something on there. And if we melt those wires, then I have a little backup wire here. We can just hook this right to the battery and then put it right onto the fuel pump. That should be big enough. So hopefully you learned something. Once again, thank you for watching as usual. Give me a little like and a comment in there if you learned something or if you have any questions. Thanks for watching.